Geometric sequence. A geometric sequence is a sequence of numbers in which the ratio of a term to the previous term is a constant, called the common ratio. Examples: the sequence 1, 3, 9, 27, the common ratio is 3. Sequence 3, 2, 4 over 3, 8 over 9, the common ratio is 2 over 3. The general term of a geometric sequence. Suppose a geometric sequence has first term A and common ratio R. Then the geometric sequence is A, the first term, AR, the second term, AR square, third term, and AR to the power n minus 1 is the nth term. The general term of the geometric sequence is Tn equals to AR to the power n minus 1. The common ratio R is equal to T2 over T1 or T3 over T2, or the general term of R is Tn over Tn minus 1. Example 1. Find the first four terms of the geometric sequence. A, An equals to 3 power n. B, An equals to 100 times 1 over 2 to the power of n minus 1. Replace the n formula with integer from 1 to 4. A1, 3. A2, 9. A3, 27. And A4, 81. The first four terms are 3, 9, 27 and 81. Same with B. Replace n formula with integer from 1 to 4. A1, 100. A2, 50. A3, 25. A4, 12.5. The first four terms are 100, 50, 25 and 12.5. Example 2. Write a formula for the nth term of each geometric sequence. A 0.3, 0.03, 0.003, 0.0003 and so on. We know that the first term A is 0.3 and the common ratio R is 0.1. Substitute A and R into the nth term formula. So the Tn is equal to 0.3 times 0.1 to the power of n minus 1. For B, 2, negative 6, 18, negative 54 and so on. The first term is 2 and the common ratio is negative 3. Substitute A and R into the nth term formula. So the Tn is 2 times negative 3 to the power of n minus 1. Example 3. The nth term of a sequence is given by An equals 2 over 3 to the power of n minus 1. A. Show that the sequence is a geometric sequence. B. Which term of the sequence is 64 over 729? Given the An formula, now to find the An minus 1 formula, we have to substitute n minus 1 into the n formula. The answer of An minus 1 is 2 over 3 to the power of n minus 2. So, the common ratio R is equal to An over An minus 1. Substitute the value and simplify until we get a constant number 2 over 3. Since the common ratio is a constant, the sequence is a geometric sequence with a common ratio 2 over 3. For B, let Tn equals to 64 over 729. By comparing both sides, we get the value of n is equal to 7. So, 64 over 729 is the seventh term. Example 4. The third term of geometric sequence is 15 and the sixth term is 120. Find the first term and the common ratio. Given T3 equal to 15 is equation 1 and T6 equals to 120 is equation 2. Using simultaneous equation, find the value of A and R, where R is equal to 2 and A is equal to 15 over 4. Sum to n terms of a geometric sequence. Sn equal to A times 1 minus R power n over 1 minus R for R less than 1. Or Sn equals to A times R power n minus 1 over R minus 1 for R greater than 1. Example 1. Find the sum to 8 terms of the geometric series 2 minus 6 plus 18 minus 54 plus up to infinite numbers. A is equal to 2, R is equal to negative 3. Substitute A and R into the Sn formula, which is n is equal to 8. The answer is negative 3280. Example 2. Find the sum of a geometric series of summation of 100 times 1.05 to the power of j from 0 to 10. Expand the summation into a series. We see here A is equal to 100, R is equal to 1.05 and N is equal to 11. Substitute all the value into S11 and the answer is 1420.68. Example 3. In a geometric sequence, the sum of the 6 terms is 9 times the sum of the first 3 terms. Find the common ratio. From the information above, S6 is equal to 9 times S3. Substitute the formula into the equation and then simplify, so the R is equal to 2. The common ratio is 2. Example 4. Find the sum of the first n terms of the geometric series 1 plus 5 over 4 plus 5 over 4 square plus up to infinite numbers. Find the least value of n such that the sum exceeds 20. From the series, we get A is equal to 1, R is equal to 5 over 4. Substitute A and R into the Sn formula. From the above information, Sn is greater than 20. So, substitute Sn greater than 20 and simplify until we get n is greater than 8.03. So, the least value of n is 9. Sum to infinity of a geometric series. From the Sn formula, if R is in the interval negative 1 to 1, then R to the power of n approaches 0 as n approaches to infinity. So, the sum to infinity of the geometric series is given S infinity is equal to A over 1 minus R if absolute value of R is less than 1. Example 5. The second term of a geometric series is 32 and the fifth term is 4. Find the first term, the common ratio and the sum to infinity. From the above information, we know that T2 is equal to 32 and T5 is equal to 4. Using the simultaneous equation to find the R. R is equal to 1 over 2. When r is equal to 1 over 2, a is 64. Substitute r and a into the sum to infinity. So S infinity is equal to 128. Example 6. Express the recurring decimal 0.45 dotted at 4 and 5 means 45 is repeated as a fraction in its lowest term. 0.45 when 45 is repeated is 0.454545 and so on. Simplify into a series until we see the pattern of the sequence is geometric series. Now we see A is equal to 0.45 and R is equal to 0.01. Substitute A and R into S infinity. So S infinity is equal to 5 over 11 in its lowest terms. Example 7. Express the recurring decimal 0.1576 when 576 are repeated as a fraction in its lowest term. Expand 0.1576 when 576 are repeated. Expand into a series. Simplify until we see the pattern of the sequence. So here we see the second term and so on is the infinite series, which is S infinity. So here we see A is equal to 1 and R is equal to 10 to the power of negative 3. Substitute A and R into S infinity. So the answer is 10 to the power of 3 over 999. And now 0.1576 when 576 are repeated is equal to 1 over 10 plus S infinity here. The answer is 35 over 222.